Again, welcome back to CS628 class. And before we start using the NumPy package, I want us to understand the basic concept of matrix. If you already know what is a matrix and also how to perform a matrix operations, then you can skip this video. In my next videos, I will use the NumPy package, the Python NumPy package, to do matrix operations and also scalar matrix operations. So first, what is a matrix? Here, the definition said a matrix is an array of numbers. Normally, this is a matrix. The size of this matrix is 2 by 3 because we have 2 rows and 3 columns. Now, the values inside, we call it the elements of the matrix. So here we have 6, 4, 24, 1, -9, and 8 are the elements of this matrix. Again, the size can be any size. It can be 4 by 10, which means we have 4 rows, 10 columns, etc. Here we have, again, 2 rows, 3 columns. Now, first, we're going to do a multiplication of matrix with a single number. Normally, we call a single number a scalar. So here we are doing a scalar times a matrix, multiplication or a product. Now, a vector will be 1 row or 1 column of a matrix. So when we have a matrix, let's say only 1 row, let's say 1 by 3, only 6, 4, 24, then we can say it's a vector. So yes, let's see how this multiplication works. Now here we have our scalar value, which is 2. We are going to multiply 2 by the matrix, and the matrix size here is 2 by 2 because we have 2 columns and also 2 rows. Normally the size, again, we start with the row first and the column. So 2 rows, 2 columns, 2 by 2. And normally we also call this a square matrix because the number of rows and columns are the same. Now we have these 2 here. We are going to multiply these 2 by every element in the matrix. So to multiply 2 by the matrix, we are going to multiply 2 by 4, which gives us 8. Then we multiply 2 by 0, which gives us 0. Then we multiply 2 by 1, which gives us 2 here. Then we multiply 2 by -9, which gives us -18. So this will be our solution. The elements will be 8, 0, 2, -18. So again, to multiply a single value or a scalar to a matrix, you just have to multiply the value to all the elements in the matrix. Now, next section, which is our main objective in this lecture, is how do we multiply 2 matrices together? So how do we multiply a matrix by another matrix? Now we have one condition. The number of columns of the first matrix on my left should be equal to the number of rows in the matrix to my right. So here we can see the matrix here we have 2 by 3, which means 2 rows, 3 columns. My first matrix on my left, where the cursor is. Now my second matrix, we can see that we have 3 rows and 2 columns to my right. So this condition is met. And we're going to explain why this condition is important. So again, the first matrix on your left, the number of columns is what? 1, 2, 3. The second matrix to my right, the number of rows is what? 1, 2, 3. So this will work. So here we are going, the reason why is so we are going to take the first row of the first matrix on my left, and we are going to multiply each element with each element on the first column of the second matrix. So this is the reason why, for example, if on my first matrix on the left, the number of column is 2, and my right, the number of rows is 3, then we are going to leave one element that will not multiply the matrix. So again, the number of columns in the first matrix on my left should be the same as the number of rows, second, again, matrix on my right. So what we do is that we take 1 times 7, then we take 2 times 9, then we take 3 times 11. The three answers that we get, we add all together, and that was what gave us 58. And we can see it right here. So again, the first column is 1, 2, 3, and also the first row the first row for the excuse me, we have 1, 2, 3 here. The row, then the second 7, 9, 11. So those are the two values here. Again, 1, 2, 3 on the first row on my left matrix, or the first matrix, and also the first column, my right side, the second matrix. So 1, 2, 3, 7, 9, 11. So you can see what we did. We multiply 1 by 7. So 1 times 7 plus 2 times 9 plus 3 times 11. When we add all together, we get 58. So 58 will be here. Then we can do the same thing for our second column in our second matrix. I will take the first. Now, the position of the value tell us which row and column we multiply. So you can see 58 is in where? The first row and the first column. Why? Because we multiply the first row with the first column. Now, the next, I'm going to multiply the first row with the second column, which means the answer will be where? The first row and the second column. And that's what we are doing here now. So we take the first row again of the first matrix, we multiply by the second column. So the result will be in where? The first row and the second column, because we multiply the first row and the second column. So the same thing, 1 times 8. Actually, we wrote down the values here. So the first row here, 1, 2, 3. The second column for the second matrix is 8, 10, 12. So we multiply 1 times 8, which is 8. 2 times 10, 20. 3 times 12. And then we add all the values, and that will give us 64. Then after that, we do the same. Now we finish with the matrix on our left side. The rows, we finish with it. So the first row is finished. We go to the second row. So that's where we're going to multiply 4 by 7 plus 5 by 9 plus 6 by 11. And that's what they have here. The answer is 139. Now, since we use the second row and first column, our answer will go to the second row and first column. So the answer will be here, 139. Again, second row, first column. And the last one will be, again, the first matrix, second row, the second matrix, second column. So the answer will be here. And that's what we have, 4, 5, 6. Then 8, 10, 12 is here. So we multiply 4 times 8, 5 times 10, 6 times 12. The answer we get will be 154, and that goes here. And that will be our final solution. So the matrix of the left side, the first matrix times the second matrix will give it this solution. Now we can see the answer is 2 by 2. Why? Always the answer will be the first matrix, the number of rows, and the second matrix, the number of columns. And that will be the size of your matrix. In this case, it's 2 by 2. Because the first matrix, the number of rows is 2. The second matrix, the number of columns is 2. So you get 2 by 2. So that's the whole idea of matrix multiplication. Now, when we are using Python, we don't need to worry about all this. We are just going to use the function, but it's good to understand the whole concept. Another example is given here. So here we are using an application, and we're going to solve it in the form of matrix. So we have the apple pie price, the cost, cherry pie's cost, blueberry pie. So we arrange them, the prices, and we have 4 days, Monday, Tuesday, Wednesday, Thursday. So this means on Monday, the apple cost was $13. Let's say on Wednesday, the blueberry price was 0. Or Tuesday it was 4. Now we can do any operation, depends on what the question is about. So I'm going to skip all this section. Is an application, but when we convert the application, this is what we get. And actually this application, This is not the price, this is the quantities. And these are the price. Now we want to know the total cost for everything. So which means we are going to have a matrix of the price times all the items here. Now, can you be able to do the multiplication? Yes. If only the number of columns in the first matrix is the same as the number of rows in the second matrix, which is correct because we are going to arrange the 3, 4, 2 as a vector horizontal. So we are going to have 3, 4, 2 values. So that means we have 3 columns and the number of rows also is 3. So we convert this and we have this. This is the dollars, 3, 4, 2. And these are the quantities for the Monday, Tuesday, Wednesday, Thursday. So when we look at this, we can find the total cost because the total cost here we are going to get will be for each again day. So here we can see the first matrix is how many columns? 3. The second matrix, how many rows? 1, 2, 3. So we can do the multiplication. The same thing we did previously. Multiply 3 by 13 plus 4 by 8 plus 2 by 6. Then we get 83. Then the same thing, multiply 3 by 9, 4 by 7, 2 by 4. If you add all, you get 63. So we keep doing this until we finish. Next, I'll multiply 3 by 7, 3 by 4, 2 by 0. The total will give me 37. And the last one, 3 by 15 plus 4 by 6, 2 by 3, and I'll get 75. So this is the solution we are going to get from this matrix again, multiplication. So the year they said that they sold $83. Again, this is an application problem. We can see that the column represents the days and the number of quantities we have for each product. And then we have the price for each product here. So if we know the price for each product and the quantity for each day, we can tell. So here, Monday is $83, Tuesday, the total was 63, etc. So here again, the whole idea is how we use matrix operation. Here we are more concerned about products. Addition, subtraction is very straightforward, but we have one rule about addition and subtraction. Let's see if we have that. Again, we don't have the application here. So what will happen is that in addition, subtraction, it's not here. The reason why, again, is very straightforward. So if I'm going to, I cannot add these two matrices. We cannot also subtract, because addition and subtraction means the size of the two matrices must be the same. So let's assume the size of this matrix is 2 by 2. So we have 1, 2, 4, 5, then 7, 8, 9, 10. Let's assume that. So to add the two numbers, I will just add each number at the correct position. So 1 plus 7 will be 8. So that will be the new correct answer. Then 2 plus 8 is 10. Then 4 plus 9 is 13. Then 5 plus 10 is 15. Then that's it. So the number of rows and columns must be the same for both matrices, because you're going to add at each position respectively. For example, 1 is in position row 1, column 1. So you add it to the next value in row 1 and also column 1. And we keep doing that. So that will be the conclusion here. Again, the main goal here is just to understand the theory behind. Also, for example, in a NumPy, the Python package NumPy, we can also use it to create identity matrix. Identity matrix is a matrix that we have 1 at the diagonal area and the rest of the elements are 0. So here we see identity matrix is the matrix equivalent of the number 1 on the again diagonal. Then the rest of the value are 0. And also identity matrix has to be a square matrix, because if it's not a square matrix, you cannot get a diagonal line. And also the order of operation is the same as regular multiplication. And before we go, this is another trick here. For example, in mathematics, we know 2 times 3 is 6. That's 2 times 3 is 6. And also 3 times 2 is still 6. But matrix is not that. Matrix A times matrix B is not the same as matrix B times matrix A. Even sometimes we cannot even do the multiplication because of the rule. You can only do matrix A times B and B times A, which will give you different answer. But if the matrix size is a square matrix, what I mean by square matrix is that the number of rows and the number of columns are the same, so it doesn't matter no more. So the example is given here. You can see these two matrices, they are all square matrix, 2 by 2, 2 by 2. So I can multiply A by B and also multiply B by A. And when we go through all the process, the same process, but you can see the answers are different. Now, with the first example we went through, which is this example, I can multiply the first matrix by the second matrix. But if I change the position, if the second matrix is the first matrix, I cannot do the multiplication. Why? We said this is correct. Why? Because the number of columns is the same as number of rows. But if I'm doing from the first matrix is our 7, 8, 9, 10, 11, 12, what will happen? The number of columns is 2. But how many is the number of rows? Well, if the number of column here is 2, and then the number of rows is, okay, number of rows will be at 2, so we can do it. But also one thing that we want to mention, which is very important, is that even if you have 2 matrices, you change them, you can't get the same answer. And one more time before we leave again is that this matrix, again, the size is important. Anytime you're doing the product, the number of columns in the first matrix should be equal to the number of rows in the second matrix. Now, if this is my first matrix, the number of columns is 2, the number of rows also is 2. We can still do it, but we will not get the same answer as we proved it earlier. So that will be the conclusion of these lectures. And this lectures is just for us to understand the theory behind matrix multiplication, etc. So our next lectures, we're going to do the non-pi examples operations. So thank you.